Okay, let's look at some examples of piecewise functions for just more practice. This first one, we've got the function is equal to, it has two pieces, 2x plus 1, and that's for x less than 0. If we want to put that in interval notation, that would be negative infinity up to but not including 0. And then it's equal to square root of x for x values that are equal to 0 or greater. So in interval notation, we would use bracket, 0, comma, infinity. Okay, so let's just start with that first piece. We're just going to look at the 2x plus 1. Okay, so that's what we're going to look at here. And we only want values of x that are less than 0. So I have listed 3 or 4 x values that we can plug in. So if we plug in x equal to 0, we'll get 2 times 0 plus 1. Well, 2 times 0 is just 0, so we end up with just 1, and that gives us a point 0, 1. You can go through. Before we move on, I do want to point out that 0 is not actually included, right? It's strictly greater than. So when we go to graph this, we want to remember that that is going to be an open point. We're just going to use a circle instead of a filled-in point because it's that's not what the function is defined for x equal to 0. All right, now let's plug in negative 1. So we have 2 times a negative 1 plus 1. All right, well, that's going to be negative 1 because that's negative 2 plus 1, so we get negative 1. So that's the point, negative 1, negative 1. Plug in a negative 2 for x. We get negative 4 plus 1, so that's a negative 3. So we get the point negative 2, negative 3. And finally plug in negative 3. So we get negative 6 plus 1, so that's a negative 5. And the point negative 3, negative 5. So we can plot those. So remember that we're going to have an open point at 0, 1. And we can have closed points at all of the other places. So negative 1, negative 1, negative 2, negative 3, and negative 3, negative 5. All right, those can be connected, and that gives us that piece of the graph. So that piece of the graph represents that linear function y equals 2x plus 1. Okay, so we can now move on to the other piece. So we basically have taken care of that, 2x plus 1 for x less than 0. Now we can move on to the other piece. The other piece is the square root of x, and this is for 0 to infinity. So we can fill out the table. And if we plug in a 0, square root of 0 is 0. And 0.00. Plug in a 1. Square root of 1 is 1. And we get the 0.11. Plug in the square root of... Okay, so here I'm going to cheat. I'm not going to actually use 2. I think we should use 4, right? So if x is 4, that's going to simplify nice to 2, so we can have the 0.42. Okay, and that actually is enough. So let's plot these on the same set of axes. So 0, 0. This time it's a closed point because this is the piece of the graph that's defined for x equal to 0. 1, 1, and then 4, 2. Okay, so we can recognize the shape of this. This is one of our toolkit functions. So that piece, that green piece, is y equals the square root of x. And it's valid for x values greater than or equal to 0. Okay, let's move on to the next example. So this is number 3 of the practice problems, if you're following along with that. So now we've got f of x equals negative x squared for x less than 0. So again, that is for negative infinity up to but not including 0. And then it's equal to negative 2 for x values that are greater than or equal to 0. So this time we include the 0 and we go up to positive infinity. So we're going to, again, we're going to start with just one piece, the negative x squared. We're going to plug in values of x that are negative. We'll also plug in 0, but we want to remember that we're going to have an open point because x equal to 0 is not included for that piece of the function. So near negative 0 squared is just 0. So we get that 0.00. Negative out in front of negative 1 squared. Well, negative 1 squared is just 1, and then that negative outside of the parentheses applies, so we get negative 1. So the point is negative 1, negative 1. And we plug in a negative 2, so we have a negative out in front of negative 2 squared. We square the negative and the 2, so we end up with a 4, and then the negative out in front gives us a negative 4. So we get the point negative 2, negative 4. All right, this next one isn't actually going to fit on the graph, but if we plug in a negative 3, we're going to get, we square that negative 3 and get a 9, apply the negative out in front, and we get negative 9. So that would be the point, negative 3, negative 9. All right, so let's plot those. All right, we got 0, 0, but that is an open point. Negative 1, negative 1. Negative 2, negative 4. And the negative 3, negative 9 is somewhere down here. All right, but we can connect those. And that gives us the piece for y equal to negative x squared. Okay, let's move on to the second piece. So this one is just negative 2 for when x is 0 or greater than 0. Okay, so if we look at our table of values of x, if we plug in a 0, it doesn't matter what we plug in there, we're going to get the y value of negative 2. If we plug in a 1, we're going to get negative 2. If we plug in a 2, we're going to get negative 2. If we plug in a 3, we get negative 2. So at these points, 0, negative 2, 1, negative 2, 2, negative 2, and 3, negative 2. Okay, so if we plot these, we're going to see that we end up with a horizontal line. So 0, negative 2. This time we have the close point because it's included for 0. There's our points. And that piece of a graph is just the horizontal line, y equal to negative 2. Okay, so that is the graph of that piecewise function. Both of those things together is the graph of that piecewise function. All right, let's look at number 6 from the practice problems. If you're following along, we've got f of x equals x squared for x less than or equal to 1. So if we put that in interval notation, we're going to go from negative infinity up to and including 1. So we got the bracket. And then x plus 2 for when x is greater than 1. So we'll have parenthesis 1, comma, infinity. All right, so starting off with x squared. Just plug these values of x in. We're going to get 1 squared. All right, so we're doing this one. 1 squared is a 1. So we get 1, 1. 0 squared is 0. We get 0, 0. Negative 1 squared is a positive 1. Negative 2 squared is a positive 4. Okay, so we want to remember that we are including our endpoint here, so we are including the 1, 1 as a close point for this one. So we plot these, we get 1, 1, 0, 0, negative 1, 1, and negative 2, 4. All right, so we know that's that parabola shape. Okay, so that is the piece of the graph that represents y equals x squared. Okay, for values of x less than or equal to a positive 1. Now let's look at the second piece of the graph. So this one is x plus 2, and this is for values greater than 1. Okay, so for x plus 2, I'm going to plug in these values. If we plug in a 1, we get 1 plus 2, which is a 3. So that gives us the 0.13, and 1 is not included, so this will be an open point. And then plug in a 2, so we get 2 plus 2. Y value is 4. We get the 0.24. Plug in a 3, we get 3 plus 2. So that's a 5, 3, 5. And then a 4 plus 2, we get 6. So we get the 0.43. Or sorry, 4.6. There we go. Okay, so let's plot those on our XY axes. And so we want an open point at 1, 3, and then close point at 2, 4, 3, 5, and 4, 6, which would be like about up here. And then we can connect those. Connect it up with that open point, and that is the piece of the graph that's defined by this function x plus 2. Okay, number 7. Let's look at this one. So we've got the function is defined by f of x equal to 3 for x values less than or equal to negative 1. So if we put that in interval notation, we're going from negative infinity up to and including negative 1. So we want the bracket. And then it's 1/2 x for x values that are greater than negative 1. So we're going to use a parenthesis, negative 1, infinity. Okay, we have values of x, negative 1, negative 2, negative 3, negative 4, all to plug in. Those fit in that interval of values of x, but our function is just equal to 3. So that means that for each of these values of x, we just get a y value of 3. So our points negative 1, 3, negative 2, 3, negative 3, 3, negative 4, 3. So plotting those, we're going to include that point negative 1, 3 because it's negative 1 is included for this piece of the graph. So negative 1, 3, we get that point, negative 2, 3, negative 3, 3, negative 4, 3, and we connect those, and again, this gives us a horizontal line. All the y values are 3. Okay, let's move on to the next piece, which is y equals 1/2 x, and so that's this piece. Oh, I forgot to circle the 3 when red. Okay, so we're going to plug in values of x that are more than negative 1. We're going to plug in negative 1, but remember that that is going to be an open point. So plug in a negative 1, so we have 1/2 times negative 1 is negative 1/2. So that gives us the point negative 1, negative 1/2. Plug in 0, we get 1/2 times 0, which is 0. and plug in a 1, so we get 1/2 times 1. We get positive 1/2. And plug in a 2, we get 1/2 times 2, which is 1. So that gives us the 0.21. Okay, so let's plot those points. -1, -1/2. It's about right there. 0, 0. Oops, let's see here. You can see what I did. We want an open point there. There we go, because it's not included for -1 on this piece. And then 0, 0, 1, 1/2, and 2, 1. Connect those. And that is y equals 1/2 x for that piece. Okay, so there are some other practice problems that are included in the document posted on Foxtail, and the answer key is posted as well. These should give you a good start on finishing your assignment.